In this lecture we are going to learn about double hashing. Okay, so double hashing is another technique for collision resolution in a hash table. Okay, so we learned in our previous lectures that okay, hash table, because if you are inserting a lot of elements and the table size is at some definite constant, okay, so there will be collisions, so they are unavoidable. So now the thing is how to handle collisions, and double hashing is one of the method to do so. So again, so the strategy for collision resolution here is that of closed hashing, where if we find that okay, if let's say some element x comes and we find that h of x, the cell in the hash table, is already filled, we try out new locations given by hix is h of x plus f of I and modulo table size. Okay, and here the strategy fi decides, the type of function fi decides what is. So there was fi is equal to I, then it was linear probing. If it was I square, it was quadratic probing. And now we are having a double hashing. So in this f of I is given by I into hash 2x, where hash 2 is another hash function that we are taking. And we apply a second hash function to x, and then what happens, f of 1 will be 1 into hash 2x, f2 will be 2 hash 2x, f3 will be 3 hash 2x, etc. And one of the good hash second hash function is r minus x mod of r, where your r is a prime number. Okay, so r is a prime number which is smaller than your table size, and it is a prime number. So in our case, in this example, we are taking h of x as x modulo 10, and h2x will be 7 minus x mod of 7. So we choose 7 because 7 is a prime number and it's less than the table size, so it should work fine. And the important thing here to note is your second hash function should not evaluate to 0, because then what will happen, see the disaster that will happen. If it evaluates to 0, then you try out multiple times f1, f2, f3, because this is 0, so it will always give 0. I into any hash 2 x which is 0 will give 0, so there will be no probing at all. Okay, so no new locations would be found. So next, let's see. Okay, so let's try to see what happened here. Okay, let's try to find what happened. Okay, so this is there, and now we go, where are we going? Okay, so here it comes. Okay, so sorry for that interruption. Okay, again interruption. So this is there now. The hash function hash 2x must never evaluate to 0, because we know that hi of x is I into hash 2 of x. So if your hash 2x somehow evaluates to 0, then there is no point in evaluating hash 2x, hash 3x, because all of them will be 0. Okay, so for example, hash 2x is x modulo 9. If we take and try to insert 99, it will become 0, and then there will be problem. A function, as we discussed, r minus x modulo r, where r is a prime number less than the table size, works well. Now what we want here is that now we should have something we try out. We have here h of x is x mod of 10. Okay, and h2x is 7 minus x mod of 7. So we try to insert now these items. Okay, 89, if I insert, so it will be initially hix, so we know it is h of x plus f of I mod table size. Okay, so hix is this. So now f of 0 is 0. Okay, so that's the for this strategy for the closed hashing. So what happens? 89, it will be just 89 modulo 10, it is 9, so this will come to the place. Okay, so we cannot see in fact, so let's put it here. Okay, somewhere here, so a lot of logistics problem. So now 89 would come here, then we want to insert 18. So again 18 modulo 10 is 8, we will insert 18 here. So now the state is 18 and 89 are here, there is no collision. Next one 49 comes. Now if you see 49 modulo 10 is 9 and there is already an element 89 here. So we will try out h1 of 49, which will be 9 plus f1. So it will be this, I need to calculate hash 2x will be 7 minus 49 mod of 7. So 7 minus 0, which is 7. So 9 plus 7 percentage 10. So 16 modulo 10, which is 6. So this will be the state now. So it will come here 49. So we have 18, 89. So these are the cases. Next, what happens? We try to insert 58. 58 modulo 10 will be 8. 8 is already filled with 18. The cell 8. Next, we try out the next location. So hash 2x is 7 minus 58 modulo 7. So 58 modulo 7 is 2. So this becomes 5. So your h1 of 58 will be 8 plus 5 modulo 10. So 13 modulo 10, which is 3. Okay. So 58 will come here. Okay. It will be in 3. So 58, 49, 18, 89. Now finally let's try to insert 69. So 69 modulo 10, okay, is 9. Again this place is already filled. So 69 we find hash 2x. So 69, for that hash 2 of 69 becomes h269 will be 7 minus 69 modulo 7. So it is 6, 1. So what happens is that h1 of 69 becomes 9 plus 1 modulo 10. It becomes 0. So 69 goes to this 0. So 58, 49, 18 and 89. So this is how the table looks like after these many insertions. So now we see this hash 2 while we were calculating. So it gives us fast collision resolution. Okay. So this is the strategy that is known as double hashing. So I hope you understand this. Thanks a lot.